Good morning, everyone. Good afternoon. Good afternoon, everyone. Welcome to this, perhaps the last training program for round 2. And yeah, a very warm welcome, considering that it is such a terribly cold day. I'm here in Durban, and at 14 degrees, it is quite unbearable. And I would imagine many of you are out in much colder areas, especially those in the inland, Gauteng. I hope you are well surrounded by heaters as I am. All right, I'm glad to see so many of you. Well, actually, the number of participants is much fewer than we normally have, but that is understandable. I'm interested, I'm impressed by the fact that many of you still want to come back and see how you have done in round 2. All right, without much further ado, we'll go straight to the round 2 paper. And as usual, I have it on PowerPoint, which I'm going to now share with you. Sorry, I can't understand what's going on here. Just bear with me. I'm not sure what's going on. Oh, okay. Now I know what's going on. Okay. So, all right. Okay. Do you all see the screen?
Yes, Prof.
Okay, good. Thanks for answering. Thank you. Okay, let's go on to problem 1. I found that this particular paper was not as challenging as some of the other papers. So I hope that many of you have done fairly well. But on the other hand, the competition would have been much keener. The first question, it's a simple subtraction sum. This year is 2021. In how many years will it be 2023? You simply subtract it and you get 202, I presume. So we wouldn't waste time with that. That's a grade 4 question. Let's go to problem 2. Problem 2 says, if a times 4 equals b, and b minus a is 33, then what is the value of a? All right, so a times b, that's 4 times a, is 4a is equal to b, so b is 4 times a. And the difference, b minus a, is 33. So So B is 4A, according to that. So you have 4A minus A, which is 3A. 3A is equal to 33. So A is equal to 11. 3A is 33. If A is 11, oh, that is what they want. So that's a rather easy question, an easy answer. We're on to problem number 3. So that can be done mentally. Problem number 3, we have a diagram here. So evidently it's a geometry question. And you have this kind of a zigzag shape. You're given 2 angles and you're asked to calculate the third one. And yeah, at first glance, this looks like a very difficult problem because there are no triangles or any quadrilaterals or anything here. So how are we expected to find the value of x? So the problem is actually to perform a construction to solve this problem. Now, there are 2 possible constructions one can solve. The one is where you try to create a triangle. Okay, and to create a triangle, what I can do is I got a 26 degrees here, and this is an x degrees here. So it'll be reasonable to expect, if I need a construction, to extend this line. So now I have a triangle, right? And once you've got a triangle, then we can use the properties of a triangle to solve this. Now, let's see, this is x. Clearly, it's an exterior angle of this triangle. And one of the angles is known. So we would be able to calculate this provided we know the other angle. And that angle now can be calculated because this angle here is 130 degrees. And these lines are parallel. So these 130 and this unknown angle are actually co-interior angles. So if one is 130, the other has to be 50. Because co-interior angles, what we call the U angles, are supplementary. They add up to 180. So this is 50. Now you have the interior opposite angles. So from the theorem which says that an exterior angle is equal to the sum of the interior opposite angles, you got your flag here, right? So these 2 angles of the flag will give you the third one when you add them. So this is equal to 76 degrees. 50 plus 26 is 76. There is another way of doing this, and that is by, see, we performed this particular construction, but we could have constructed a third line parallel to the 2 given ones. So we could have drawn a new line here, which is parallel to the 2 parallel lines. That'll help a lot too, because now you've got 3 parallel lines. This is 26. So therefore, this angle here is the alternate angle to that. So that's also 26. And this angle here, this line is parallel to this. So this angle here will have to be 50 degrees because these lines are parallel and these are co-interior. And then the angle that we're looking for, x, is actually equal to 50 degrees plus 26 degrees. So you can break this angle up into 2 pieces, one of which is 50 and the other which is 26. So you come back to the same answer, 76 degrees. All right, so there are 2 possible constructions. Maybe there are others, but So this is a problem which involves a construction. And it's not often that in the junior grade, you have problems with constructions. Constructions are usually for advanced students, but I don't think this was totally unfair. All right, so the next problem now is, go to problem 4. Okay, so problem 4 is on the screen. Here we have a solid. Oh, by the way, I put up the question paper on the Google Classroom on Tuesday. How many of you had a look at that question paper and tried to go over those questions again? Just by show of hands, can you please tell me? Okay, unfortunately, I can't.
Mommy.
All right. Okay, I can't see how many of you, but I hope there are a reasonable number of people who've been. You've already gone over it the first time you wrote the exam, so now I've given you a chance to look at it again to see whether you could improve your scores. So now you should be more prepared to solve these problems. So let's get to this. The question here is what is the volume of this shape here? It's a 3 by 3 by 3 cube. All right, and each one is a 1 centimeter by 1 centimeter square. So it means that all these cubes, 3 by 3, so all these cubes have got dimensions 1 by 1. Okay, so all the sides are 1 in each cube. So each cube is 1 cubic centimeter. So we need to count how many cubes there are in this picture here, which has got holes dug through the sides up to the opposite sides. So how does one count how many cubes are left? See, one way of doing it is to count how many cubes were removed as a result of the drilling of the hole. That's one way of doing it. And that it might be a challenge. We'll come back to that. But the much easier way is to simply count what we can see here. And this is the way I did it. You've got 3 layers. I can see 1 layer staring at me, the top layer, and you can see the 8 cubes there, right? And obviously the bottom one will also have 8 cubes. So that makes 16. So the only thing we have to do is to count how many cubes there are in the middle layer, which is sandwiched by the top and the bottom layer. And you can see clearly the middle one has got 4 cubes there. So you got 8 plus 8 plus 4, which gives you 16 plus 4, which is 20. So the one way of doing this thing is to count the number of cubes that we can see layer by layer, and you'll have the top plus the bottom plus the middle gives you 20 cubes, and each cube is 1 cubic centimeter. So 20 of them will be 20 cubic centimeters. The more difficult way is to know that if this cube was full, if there were no holes dug, right, the volume will be, it's a 3 by 3 by 3, so the volume would have been 27, because there would have been 27 cubes here, right? But now, many of them are removed. And how many are removed? Well, now that we know the answer, you can see that 7 of them will be removed. But it's not easy to see which 7 are removed. But I can tell you, there are 6 faces. In any cube, there are 6 faces. You got the top, the bottom, and the 4 faces right round. Right? So there are 6 faces, and each face, there's a hole removed from it, right? As you can see. So that gives you 6 holes. But where is the 7th one coming from? 7th one is coming from, anybody knows?
The center.
The center, right? So you've got the 6 holes on the side and the center hole. That makes 7 holes, and 7 cubes which have been removed from a 27 one. So the resultant one will be 20. So that's the other way of doing it, which I think is a little bit more difficult. It's not easy to see, but this is much easier to see. Okay, so let me just pause and find out from you guys. Oh, now I can see hands raised. Yeah, now so far we've done 4 problems. How many of you think you got all 4 out so far? Raise your hands, please. Come on, there would be many more. Don't be shy. There is a little logo thing there which tells you reaction. Go to reaction and go and raise your hand. All right, so maybe so the 11 people who got whole 4, correct? Okay, so maybe most of them would have been stumped with problem of number 4. Okay, so let's go to problem number 5 now. Problem number 5. It says each of the 10 parts shown is 1 meter long. Are there 10 parts? Let's see now, you got 3. How do you count them? Okay, let's count this direction. 2, 4, 5, right? And then the other direction, there's another 5 there. Okay, so there are 10 parts. An ant walks from point A to point B without going through any path more than once. So you don't want the ant to go and return to base. So it just goes through each path exactly once. The question is, what is the length of the longest possible route? Now, the challenge here is that you can choose a route, but how do you know it's the longest possible one? Okay, now that requires a little bit of thinking. Okay, we can try one. Let's try this one here. We want to choose a route which is going from A to be as long as possible. So let me change the color so that we can see what we are doing. A nice color. Standard color is red. Okay, so let's just go down from A to this point. That doesn't look like red, it looks like white. Okay, let's go from A to this point here. There we are. Right, and then O. And then from here to here. Right, now, if we want to go to as many as possible, let's change direction. Don't go towards B, change direction. Now, when you come here, you got no choice. You can go back there, but then it means we have to retrace our steps, which you're not allowed to. So we go here, and then now we've got no other choice. We have to go, oops. You can come down here. And then we don't want to land up at B too soon. So then that's nice. We can do this. And then we can do that. We can do that.
Huh?
Yes, sir. That's one way of doing it. Somebody has got a comment to make. Let me just finish this. There are 2 which are missing, this one here and that one. So those are the only 2 which haven't been traversed by this route. And there were 10 possible paths. So this particular route has got 10 minus 2, which is 8. Right. Now the question is this the longest? First, somebody has got a question? All right, nobody has got a question. But is there anybody who can argue that there is no path which is either 9 or 10 centimeters long? We want to say that this is the longest. Come on, the floor is now free. So how do we argue that this is the longest possible path? It's important. Just choosing one and intuitively saying, well, I don't think there's anything bigger. And it doesn't look as if there's anything bigger because we kept moving away from B. So we tried to make it as long as possible. But there is a logical argument. I thought I might give you a chance. All right, nobody wants to hazard a guess. Andreas? Put your mic on, Andreas, so we can all hear you.
Okay. Uh, if you were to look at it, we start from A, then when we go, we, when we use it, the first line we have, of course, the options. Then the second line we can uh, go. But then if we were to make nearly and square with the third line and square with one side missing, then the fourth line would not be able to go to fill in that side because then we would be stuck. That is at the start, I know it would be like so. Then we won't be able to use that last
So you are
piece.
saying we can't use this line here. Right, we cannot use this line. And
Okay,
likewise, you cannot use this line here, one of these lines. Okay, Andrea, I think you got I think you got the crux of it. But if you want to summarize what you are saying is that from A, you can choose only one path. It's impossible to choose more than one path from A, right? There can only one path that you can choose from A. As you pointed out, otherwise you have to return to A, and then that means now that you'll have to use some path twice. And likewise, you can only use one path going to B, right? Only one of these two. So to get to B, you lose one. To leave A, you lose one. So you'll always lose two, right? And we've got 8. So so that means we have used 2 and no more. So that's the longest path. Okay, thanks for that, Andreas. Okay, so now that's problem number 5. How many of you got length 8? I'm sure many of you did get it. Okay, good.
Sir, I also can't see your screen right now.
Okay, now can you see my screen?
Yes.
Right. Okay, so let's get on to the next problem. The next problem is problem number 6. Which is saying,
Huh?
yes, Wade, you have a question, Wade? Okay, I'll proceed. Please switch your mics off. You can speak.
Oh no, sorry, sir.
Yeah. Please switch your mics off. And when you're speaking to me, you can put your mics on, but remember to take it off. All right. So yeah, you got this Ferrous wheel. Let's see. It says if the three numbers along each diagonal are added, well, how many diagonals are there? Looks as though there are lots of diagonals, but actually you've got one long one. Oh, if you count these two, which are perpendicular to each other, those are two diagonals. Then you have just two more. This looks like the x-axis and the y-axis here. And then there are two more. So there are four. There are four diagonals. Right. So if the three numbers along each of these four diagonals are added, right, there are three numbers in each diagonal. The average of these sums is 25. Okay, so you got four numbers, and the average of those four numbers, because you got four diagonals, so therefore you got four answers. The average of these four numbers is 25. What is the value of x? Okay, so let's just figure out. First, we have to see what are the four numbers. Well, let's take the diagonal with 1 in it. And it goes down here, and when you add these three numbers, you get 9 plus x. That's the diagonal with 1 in it. The diagonal with 2 in it, that's also 9 plus x. The diagonal with 3 in it, they're making it very easy for us to count. Okay, so all these four diagonals has got 9 plus x because the opposite numbers add up to 9. So what is the average of these four? The average of these four numbers, they're all equal, right? So the average is 9 plus x. So the average of these four numbers is 9 plus x. But they say that the average of these numbers is 25. So therefore x must be 16. Okay, so it's not, I didn't have to calculate any averages, because when I take each of those three sums, they're all the same. I don't have to average of four numbers which are the same. It's just the same number itself, obviously. And that average is given. So it's quite an easy problem. It can be more complicated, but like I didn't see that solution, I must say. Only when I saw it now, I see the solution. But when I wrote it out, you will see just now that I had something much more complicated. So you can replace my solution with this one. See, I've got a whole long story here, adding up all these things. I should have said 9 plus x, average is 9 plus x. And I brought in 100 and so on and on, made it all very complicated. Okay, now let's get on to problem number 7. Okay, I want to write a list of consecutive positive integers which are all next to each other, consecutive, starting with the 1. Okay, so I'm writing a list, starting from 1. So let's start to write the list. 1. Okay, what's the next number? The list must contain, they're consecutive. All right, so the next number will have to be 2 and 3 and so on. So we already know what these numbers are. But the list must contain 3 square numbers. Okay, 3 square numbers. I've already got 2 here, having gone up to just this point here. 3 square numbers. And 3 cube numbers. Oh, okay. So the only cube we've got is that one. Let's go on. 5, 6, 7, 8. 8 is a cube. That's 2 cubes. 9 is a square. All right, so I need to get past 9 because I've got my 3 square numbers, but I only had 2 cube numbers. So I need to have one more cube number because you need to have 3 cube numbers. I already got the square numbers. Now the next cube number, this is 2 cubed, the next cube number will have to be 3 cubed, which is 27, which is pretty far off, far down the line. So I can go right up to 27, and only when I come to 27 do I have 3 cube numbers, and of course, at least 3 square numbers. You've got many other square numbers there. But this is the smallest number of integers that can be in my list. I can't have 26 because if it came to 26, I still will have only 2 cube numbers. I have to get to 27 to get to 3 cube numbers, right? So this is the smallest one. I don't have to make it any larger. So the question is, now what is the question? What is the smallest number of integers? So how many integers are there in this list? Well, you can see the answer is 27. That's straightforward. No complicated way of counting those. All the natural numbers from 1 to 27, there are 27 numbers. Okay, so that's problem number 7. And now I want to go to problem number 8. Okay, a rectangular sheet of paper has dimensions 10 by 15. Okay, there is a rectangular sheet of paper, but lots of things have been cut out from here. Okay, so we're referring to this large rectangle. So what was the original rectangle? Let's just draw that rectangle, which was there. So that was the original rectangle. And then these pieces, it says here, from this sheet, 12 squares have been cut out. You can see each side has got 3 squares cut out. So there are 12 squares cut out. And I've just drawn the full rectangle right round. Now the question is, what is the perimeter of the resulting shape? Obviously in centimeters. Now the perimeter of the rectangle is, we don't want the perimeter of the rectangle, but just for interest's sake, if we look at the perimeter of the rectangle, okay, so you add up the perimeter means you're adding up all the edges, okay? And with the rectangle, you already know a formula for it, but now at high school, you don't worry about formula. You can just see I'm going to add up. This is 15 here, and that is 10. This is 15, and that is 10. So you add up the edges, you're going to get 2 15s and 2 10s, which is 30 plus 20, which is 50. So that's the perimeter of the rectangle, but that wasn't asked for. They want to know the perimeter of this funny shape. Okay, so we have to think now, how do we get the answer to that? And evidently, we have to use the rectangle, the perimeter of the rectangle somehow. The answer is that, you see, this part here, the perimeter of the new shape and the original rectangle would have contained this. So the differences occur in these cutout pieces. In the original thing, I had this line here was added, which is the same as saying I'm adding this line here. Right? So when you add that together with this, together with this, together with that, and so on, all these black lines that I've got, together with the remaining edges, you're going to get 60. So, but that doesn't give you the perimeter. I've got that together with these edges at the bottom here. But in each case, I got two things which haven't been added, those two. So these two would have given you two more, which has not been counted. This two here, again, they will give you two more, which hasn't been counted. So each one of these 12 have got two uncounted sides in this number. This number is the same as that plus that plus that plus that plus that plus that. And that is falling short of the perimeter that we are looking for. It's falling short of it by 12 twos. Because it's missing these two, it's missing those two, and missing those two. Right? So you have to add those 12 of them times 2 to get the actual perimeter that you're looking for. Okay. So that's the answer to that problem. Problem number 8. It's 74, 50 plus 24. So let's get on to problem number 9. Hey, how many of you think you got 74? This you wrote this some time ago. Okay, good. We actually got more people who've got 74 here. It's just about half of the class, which is good. I'm quite encouraged by that. Or more than half. Okay. All right. Now let's get on to problem number 9. The sum of 5 consecutive positive integers starting with n is a perfect square. What is the smallest possible value for n? Now, I don't know whether it occurred to you as a good mathematics student who likes mathematics, you should be playing around with numbers and so on. And you might have come across at some point, it's easy to see that if I've got 5, say I got 3, 4, 5, suppose I got 7 consecutive numbers. These are consecutive. It's very easy to add 7 consecutive numbers. It's very easy to add them. Anybody knows? All you need is a middle number. If you know the middle number, then you know the sum. Suppose the middle number is 10. How many do we have? We've got 7 numbers. The answer will be 7 times 10. Right. Now, what's the reason for that? If the middle number is 10, then these would be 9 and 11. Right? So you got 1 less than 10, 1 more than 10, and you're adding these two. So those should give you 20, 2 tenths. 2 more, 2 tenths here. So there's 1 10 in the middle, and these two will give you 2 tenths. And here too, you're taking 1, 2 less, and 2 more. When you add them, you'll get another 2 tenths. And here too, you got 3 less. I'm not even writing them down. I've got 7 and 13 to be precise. So you got 7 plus 13 is 20. The reason is you got 3 less and 3 more. So you got 2 tenths again. See? So therefore you have 2, 2, 2 and 1 tenth. So we give you 7 tenths. So it's really 7 of the middle. So if you've got 5 consecutive integers, right? If you knew this fact, which I don't expect you to know, so a quick shortcut method would be, well, suppose the middle number is x. Suppose the middle number is x. Then the sum of the 5 consecutive numbers is 5x, as we just saw. Now this is a perfect square. It says so. Right. So they ask which is the smallest possible value for n? So it's the same as asking what is the smallest possible value for x? Because x is one of those numbers, one of those five numbers. So we try to make x as small as possible. So in other words, we need to make 5x as small as possible. So you want to make 5x as small as possible, but it must be a perfect square. So what's x equal to? 5x
5.
is, yes, right? 5x is as small as possible, and you want the smallest perfect square, which is equal to 5x. X must be 5, right? There are other numbers like, you can take 20, for instance. 20 times 5 is 100. But the smallest one will be 5. So the answer to the question is x equals 5. But what they are looking for is the smallest value for n, and n is the starting number. So this must be n. So the third number is 5, so n will have to be 3. Now, guys, I hope you appreciate the mathematics here. You can see we're not doing any complicated calculations or anything. They're mostly thinking. That is what problem solving is all about. To improve your thinking, your logic, look to see what's going on. These problems are involving numbers. So we're interrogating numbers and how they work, see? So you're learning a few things here. For instance, you can take 5 consecutive numbers and you're adding the whole lot. It's the same as multiplying the middle number by the number of such numbers. Because you really, when you're subtracting one, adding one, you're adding 2 of those numbers. So that argument works. All right. But I like an argument like this because this is all about problem solving. But if you didn't do it like that, then you'll say, okay, I'm starting with n. Okay, they're consecutive numbers, so we can write them down. N plus 1, n plus 2, n plus 3, n plus 4, and that's it. Those are 5 consecutive numbers. Now I'm adding all of these, so let's add them up. You got 5 n's, and then you got 1 plus 2 plus 3 plus 4. So when you add these 5 consecutive numbers, starting with n, you're going to get 5n plus 10. And then they say this is a perfect square. So 5n plus 10 is a perfect square, which is the same as saying that 5 into n plus 2 is a perfect square, right? So this is a perfect square. But this is the only place where some algebra comes in. You take out the 5 as a common factor, right? You want this to be a perfect square, but at the same time, you want n to be as small as possible. So you got 5 times something is a perfect square. So this thing here will have to be 5, as we argued earlier on. That's the smallest possible value that you can give to this thing. But if n plus 2 is 5, right, then what is n? Which number added to 2 gives you 5? The answer is 3. And that is it. That's your n, which we saw earlier on. So that, I suppose, will be a more digestible solution. Most people will do it like this. Not many people will argue this way. Okay, so let me just find out how many of you actually got this out. Are there any questions? Were there some people who had alternate solutions to that problem? Different from the one that I put down? I had 2 solutions. Okay, so nobody had any other solution. So let's get on to problem number 10 then. Problem number 10 says, from the first 100 natural numbers, so you got a lot of natural numbers, 1, 2, 3, all the way up to 100. 1, 2, 3, 4, 5, 6. Okay. Don't open your mouths. I'm not going to write the whole lot. Okay, I'll just put dot, 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 and it's going up to 100. Just remember, it's the first 100, 1 to 100 inclusive. 1 and 100. All the multiples of 2 are removed. So what you are doing is you're taking out the multiples of 2 are the even numbers. So the even numbers are removed. So what are you left with? You're left with all the odd numbers. Okay, how many numbers have been removed? The even numbers 2, 4, 6, 8, all the way up to 100. So obviously there are 15 even numbers because you get 2, 4, 6, 8 up to 100. So that's 2 times 50. So 50 have been removed. So you got 50 left here. Okay, so these are the odd numbers. Now, and then all the multiples of 5 are removed. Now, amongst the odd numbers, if you remove the multiples of 5, right, the multiples of 5 will either end in 0 or end in 5, but none of the odd numbers can end in 0, obviously. So we are looking for all those numbers which end in 5. Those are the multiples of 5. Okay, so you have 5, 10, 15, and we go all the way up to what? And not 5, no, not 10, sorry. 5, let's do it again. 5, 15, 25, 35, going all the way up to 95. And you can see quite quickly, these are all the multiples of 5 which are removed. We want to see how many more are removed. This thing is already doing the counting for you because you go 1, 2, 3 up to 9, and there's one more, so that makes 10. So there are 10 multiples of 5. You have to take those 10 away from those 50 odd numbers, and you're left with 40. That's the answer. How many numbers are left? So the first round, 50 are removed. The second round, 10 are removed. So altogether, you've got 60 removed from 100. So the answer is 40. How many of you got 40, if you recall? I'm sure you've written down the answers somewhere so that when I'm discussing it, you can check it out. All right, that's good. A fair number of you got 40. Okay, let's go to problem 11. Problem 11 says all the prime numbers less than 2021. Oh, this is a year problem. Then we have a year. Every paper will have a year problem. All the prime numbers less than 2021 are multiplied. So which numbers are multiplied? Okay, let's start. What's the first prime number? You can put your mics on. What's the first prime number?
2.
Right, now you're going to multiply this by what? All the prime numbers, right? What's the next one?
3,
Right?
4, 7.
Times. And I don't know, there's a prime number which is quite far off. We don't know what that is. So this looks like a very hard problem. You say, oh, there are so many of them. But the question is, what is the units digit? So the question is only asking about the units digit. What's the units digit?
So,
Huh?
so if you were to look, the 2 and 5 multiplied together give us 10, and anything multiplied by 10 but does add a 0 at the end.
Right. Okay, Andreas.
So
Well done.
it
So
could
the number
be
at the
as
end
a
will have to
0.
be 0 because anything multiplied by 10, this number is being multiplied by 10. Anything, we don't care about the rest of them. Anything multiplied by 10 ends in 0. So that's what they ask. The units digit is the same as what is the last digit. The answer is 0. Thanks for that, Andreas. It'll be nice if somebody else, apart from Andreas, answers these questions. Andreas is the only one who summons up the courage. So Andreas, next time keep quiet until if nobody else answers, then I'll give you the chance. Problem 12. 16 jelly tots. So you got, so the jelly tots, there are 16 of them. They are supposed to be these black things, yeah? Okay, arranged in a 4 by 4 square. As you can see. But then they are connected by toothpicks. So all these lines are toothpicks. Okay, so what is the question? So you've got a number of toothpicks here. How many toothpicks would be needed for a 10 by 10 square? Okay, now we can see there are lots of toothpicks. Let's just count them. Okay, so there are 3. Let's count all the horizontals. So you got 3 there, and there are 1, 3 in each horizontal. Okay, so that makes 12, right? So altogether you got 12 horizontal toothpicks, and let's count the vertical toothpicks. Again, there are 3 vertical toothpicks, and another 3 here, another 3 here, another 3 here. So there are 4 3s multiplied by 2. That is the important thing here. You got 3s. If you multiply the horizontal, you got 4 times 3. So there are 4 rows. And then if you take the verticals, it's another same thing. So it's 2 times 4 times 3. So that is the total number of toothpicks which are here. If you count them, you will see you get 4 times 3 is 12, times 2 is 24. You will see that there are 24 toothpicks in this diagram. All right, now you got a 10 by 10 square, right, containing 100 jelly tots. I'm not going to draw the 10 by 10 square. I'm just going to use my imagination. When I had a 4 by 4 square, I have to multiply 4 times 3. So in a 10 by 10 square, I've got 10 times 9. Same kind of argument, right? I will say that there are, each row has got 10 toothpicks, like how we had 4, and there will be 9 rows, like we had 3 rows here, not 4, right? 3 rows here. Just like that, there will be 1 less row here. So there'll be 9 rows. So 10 times 9 is 90, and you have to double that to count the columns. And the number of toothpicks you're going to have is 180. So how many of you had 180? Okay, so it's quite nice to see that in almost all cases, more than a third of the students are getting it right. So far, I think there are some people who've got a whole lot right. Are there, so far, is there anybody so far who've got all 13 right? I can see the hands are going down fast. Wow, there are 5 people who've got the whole 13 right. Well done, guys. Would you just please put that on the chat column, your names? Just put down 13 in the chat column, and I will know who you are. There should be 5 of you. Oh, there are 4. But whatever, whoever has got 13, please tell me. Oh, there are actually 12 because I'm at problem number 13 now. Okay, so this next problem is saying the positive integers x, y, and z. Now that's very important. X, y, and z are positive integers. They are numbers like 1, 2, 3, 4, 5, the kind of numbers that you were exposed to when you were in grade R. So x, y, and z are grade R numbers, positive integers. And they satisfy these three equations. So let's just read these equations in words. You got the product of two of them is 10, another two, and another two. So the product of any two, because x, y, and z, these take care of all three possibilities, x, y, y. Product of any two of the numbers is given. And the question is, what is the value of x plus y plus z? Right. So now here now, you see, sometimes too much of mathematics is a very dangerous thing. I'm sure many of you would have tried to solve this thing, write on equations and solve unknowns and so on. When you see the solution, you'll be quite shocked. Because in many cases, they use no more than primary school mathematics and common sense to ask, do you understand what these things mean? Now look, this is a factorization of 10 because you're taking 10 and you're writing it as a product of two positive integers. So likewise, you've got a factorization of 15 and you've got a factorization of 6. Right. Now there are several factorizations for 10, not so several, but there are a few. And here too, there are a few factorizations for that. So we don't know which factorization you have. But let's look at them. Look at this. In this case, if I look at it, take these two, you will see that y is a factor of 10 and it's also a factor of 15. Right, now which number or numbers is a factor of 10 as well as 15? Right, tell me.
1 and 5.
1 or 5, that is correct. Okay, so y is going to be one of these values. Okay, so let's just say for the time being that y is equal to 1, then what happens? If I put y equals 1, then x is equal to 10, because then you'll have 1 times 10. But now you've got 10 is a factor of 6 from this last one. That's not possible. Because x is a factor of 6 here, and z is a factor of 6. Each of these is a factorization. So if, I'll repeat this, if y equals 1, you come to a contradiction. Because then you get x equals 10, and then you'll have x is a factor of 6, which is impossible. So this is eliminated. So now we know exactly what the value for y is. Y equals 5. Now it's easy. Y is 5, therefore x is 2. 5 times 2 is 10. If x is 2 from here, x is 2, so z has to be 3, because z times x is 6. If you check out the other one, yz, see yz is also 5 times 3, which is 15. So this works. So we have x, y, and z, and the sum of x, y, and z will be 10. 5 plus 2 plus 3. And that's the answer. Now it'll be interesting to see. Okay, before we go on, did you all understand that logic? Put your hands up. So far I have 17, there were 18. There were 29 people. Must I understand that 10 of you, it's coming down a little bit. Must I understand that 9 of you did not understand? Okay, you can wait for me at the end of the class and I will repeat that argument, okay, to see how we get x plus y plus z is equal to 10, okay? All right, so let's get on now. And okay, the next question, how many of you actually solve the problem to get the answer x plus y plus z equals 10? Right, it's a new question. How many of you got that the sum is equal to 10? I see 19 people have put their hands up, which is quite a large number. 20. Woo. So many people got the answer. All right. So I suppose you didn't use the logic that I was using, but what you did was tried out various possibilities. And you saw that this worked. So there was an alternative way of doing this thing. But I hope you understand my logic. It gives you make the very few choices. Very quickly you can get to the answer without having a long trial and error. Okay, so the next problem is problem number 14. Problem number 14, you got, if the pattern continues in the same way, how many shaded blocks will be in figure 30? So let's see, they've got 3 patterns and you are asked to find how many shaded blocks there are in the 30th pattern. Now that's quite it's quite far away from this. So it's not easy to just draw the whole 30 and then get to the 30th one and then count the shaded blocks. It's not feasible. So we have to think of some way of actually counting and the number of shaded blocks and see the pattern. Now, I myself, I did something right in the beginning and realized that, oh, there are better ways of doing this thing. Okay, can I have some offerings? Can somebody suggest what one can do to solve this problem? How do you count the number of shaded squares?
Sir, could you repeat the question?
Yeah, the question is, do you have any idea on how to count the shaded squares so you have a pattern emerging?
You can see that there's a common difference of 3 in each figure. So then you just take figure 30 and you times it by 3 and you add the original 6. Add 6.
Oh, okay. I think you probably got the right answer, but I just want to check. There may be a small adjustment you have to make to that. But I like that solution. I didn't see that one. So what you are saying, you are actually counting these things. This is for the 9 here, and here 11. No, wait a minute.
So I think it's 12.
12. Huh? I'll come to you just now.
So isn't the pattern the figure plus 2 times 3?
Okay, let's just do this one here first. Almaz. He says you can, each figure is obtained from the previous one by adding 3 to it. I have to confess, I didn't see that one, which is very nice. So in other words, what you have is an arithmetic sequence, 9, 12, arithmetic because there's a common difference. And how many terms have you got? You've got 30 because you're going up to the 30th figure. So there are 30 terms. So the question is now, oh no, not 30. 30 terms, n equals 30. That's the number of terms. And you want to know what is t, the 30th term. That's the question. And when you do arithmetic sequences, we know that the nth term is a, which is the first term, plus n minus 1d, that's the formula. The a we can see is 9, n is 30, so that's 29, and d is 3, So that gives you 9 plus 87, it's 96. So if you do it like this, the answer is 96. And that is the correct answer. Okay, somebody else had another way of doing it. Are there any other ways of doing it?
Sir,
Yes.
what if you multiply the term by 3 and add 6? It will still equal to 96.
So what you are saying here is, you are saying this 9 here is 1 times 3 plus 6. And here you are saying this is 2 times 3 plus 6, because that gives you 12. And you're saying this is 3 times 3 plus 6, so that's 15. So therefore, the 30th one is 30 times 3 plus 6, and that gives you 96. So you are saying that you can recognize the pattern like that, which is fine, but it's a little bit more difficult to recognize this pattern here. But this is the same as what we had before, because you have a plus n minus 1d is this thing here. A is 6. No, I'm sorry, 9. D is 3. D times n minus 1d is that. When you simplify this, you get 9 plus 3n minus 3. Simplify that further, you get 3n plus 6. Now that's what he's doing. He's going straight to 3n plus 6, you see. N is 1, n is 2, n is 3. So if you simplified the general term, you will come to 3n plus 6. And he's using that formula, 3n plus 6, to calculate the 30th term. Thank you for that. That's a nice answer. Anybody else?
So if you say the figure plus 2 times by 3.
Oh, I see. So you are saying 1 plus 2 times 3. And here you are saying
Yes.
2 plus 2 times 3. And here you are saying 3 plus 2. Isn't it? That's what you're saying.
Yes, sir.
But this is the same as the previous one, you can see, because this is 3 times 1 plus 6, 3 times 2 plus 6, 3 times 3 plus 6. So this is another way of doing it. That's fine. Okay. So far I got 3. Any more? I must confess that I didn't see any of these. All right. I'll tell you what I saw, which is not it's also a little bit obvious. I started counting. I counted the columns first. Then I counted the rows, but I don't want to repeat that one. And then I counted the other ones. I got 4 plus 3 plus 2. Here I got 5 plus 4 plus 3. Here I got 6 plus 5 plus 4. See? Now these are some of 3 consecutive numbers. So it's just the 3 times the middle one, right? So in figure 1, I've got 3 in the middle. Figure 2, I've got 4 in the middle. Figure 3, I've got 5 in the middle. For figure 30, I've got 32 in the middle. So the answer is 3 times 32, which is 96. You're adding 3 consecutive numbers with 32 in the middle. That's the one I saw. Then I had one even which is far more complicated, right? But I like your people's solution. You're giving me very beautiful solutions, some of them which I didn't have. In fact, I didn't have any of the 3. So thank you for that. You've enriched me. But mind you, I have a few solutions, I'm happy to say. So this was the solution that I just told you. Oh, there's another one here. A funny looking solution. Just counting the size and the boundary and all that. Let's look at 96. And the last one is horrendous. Look at this. Whew. God forbid. That's the trouble with being a professor. You think of all professorial solutions. Don't look at the nice, clear, crystal solutions like what you guys do. You've got much clearer minds than I am. Okay, so you got problem number 15 is where I'm going to go to. The diagram shows three identical squares of side length 8 centimeters. The top square is exactly centered over the two squares below it. Okay, so this is right in the middle. Determine the area of the shaded region in square centimeters. Okay, so how does one go around doing this? There is a shaded region, but unfortunately, this shaded region, you can't break it up into smaller pictures because I can extend one to get a triangle, but the other one is not a triangle. So then I've got a lot of unknown sides. Let me just write down what sides I know first. That'll help a little bit. All the sides are 8. So you got this is 8, 8, 8, so on. Okay, and I know this part here because this thing is slap bang in the center, right? It says, so therefore this edge here will be in the middle of this, and that edge there will be in the middle of that. So this part here will have to be 4. Okay, so now you know all the edges, 8, 8, 4, 8, and there's a diagonal also. It's not quite clear how you're going to calculate that one, but we don't really need that. We need the area of the shaded region. Okay, any suggestions, guys? How do you find the area of the shaded region?
Hello.
Yes.
I draw a square to make the two triangles join to make it one triangle.
Oh,
Well, not
Roland,
a square.
what you did was you joined?
Yeah, I just joined that like a rectangle.
Like this, you joined this?
Over there. Yeah.
You joined that?
No, like a rectangle up.
Oh, I see, like a rectangle.
Yeah, to form one.
Okay, so what you did was you went up there like that, and then you push this up as well. Is that what you did?
Yes, that's correct.
Yeah, okay, that's exactly what I did as well. Because now it's easy. The area that you're looking for is the area of a triangle less the area of a rectangle. Now that's easy. Right? The area, that's very nice, Roland. Was it Roland?
Yes, sir.
Right, okay, thank you very much for that. So we have we got the area of a triangle minus the area of a rectangle. That'll give you the black part. Now, do we know what this is? Well, we just said that this part is 4, so that is 4. And this part here will be obviously 8. So now we have the dimensions of everything in sight. The triangle, the area of the triangle has got 12 on one edge and 16 on the other. So the area of the triangle is a half times 12 times 16. That's the area of the triangle. And you're taking away from it, you're removing from that the area of this rectangle, which is 8 times 4, which is 32. Okay, and if you do this thing here, half of 12 is 6, 6 times 16 is 96. 96 minus 32 is 64. So that's the answer. Right, it's a very nice solution, Roll. Anybody else got 64? Right, I'm happy to see a fair number of you guys have actually got 64, more than half the people. So it seems that all our efforts in the last many weeks have given you some nice ideas to solve these kinds of problems. I would like to think that the experience that you had in all these classes helped you to think of ways of solving this problem. Would you agree with that? Just for my own ego. All those who agree that those who got the answer, it's because you've had enough experience with areas that you were able to solve this problem. Okay, so a number of you.
Yes, Prof.
Right, okay. A number of you have
Yes.
inflated my ego sufficiently for me to move on to the next problem. I don't know any other solution. That's the solution that I got. If there were some other solutions, I would like to know them. We go on to problem number 16 now. Now, the combination of a certain block is a 4-digit number with no two adjacent digits the same. Now, these kinds of problems are non-routine, but we have done some problems where we were counting, and hopefully some of that can be used in what we are doing here on how to count. Right. So let's see. This is a combination of a lock. And I don't know how many of you will understand what that means, but I would be quite I'm quite sure that all of you will know what that means. So you got some kind of a lock. Many of these bags have these locks. And they have numbers here. And a particular combination will unlock this thing. So this combination has got these two numbers, 2, 0, 2, and 1. So you're only allowed to put 2, 0, 2, and 1, which makes it very easy to open this lock because there are very few possibilities. Usually they have, all 10 digits. So then you got a 10-digit number here, right? I mean, so a 4-digit number. Any digit is allowed. So how many 4-digit numbers are there? There are 9,999. Actually, 1,000 4-digit numbers if you include 0, 0, 0, 0. So there it will be very difficult to open it. But here they are using a very limited number. So how many combinations are possible? But they say that no two adjacent digits are the same. All right, so let's just have a look at this thing. We don't want the adjacent digit to be the same. The only digits which are repeated are 2 and 2. So we don't want 2 and 2 to be next to each other. All right, so you can have 2 and 2 here. 2 can't be here. If you have 2 in the first position, you can have 2 in the third position, or you could have 2 in the fourth position. All right, so this is how you count. Suppose 2 is in the first position. All right, then you have only 2 possibilities. Then the other 2 is in the third or the fourth. All right, now the next one is suppose 2 is in the second position. Right? Now the other 2 will have to be here. You can't have it there, but you can have it here. So you got 2 blank, and here you got blank, blank, and here you got blank, and there's a blank there. Right? 2 is in the second position, and your second 2 is here. Or you could have 2 in the third position, but that's not possible because then the remaining 2 will have to be in the fourth position. I'm counting them without a repetition. I say, suppose 2 is in the first position, count everything. Then go to second position, you avoid the first position completely now because you've counted all of them. So you only got the second, third, and fourth positions to work with. And there you have only one answer, the second third and the fourth, you can have that and that. That's the only possibility. With 2 in the second position. Now with 2 in the third position, you're not allowed to count those. And you're not allowed to put a 2 here. So there's nothing there. So there are only 3 possibilities. Now, the other 2 numbers are 0 and 1. So you can have, for this possibility here, you can put a 0 here and a 1 here, or you can put a 1 here and a 0 there. So there are 2 possibilities in this situation. Right? You can have 2 0 1 2, 2 0 2 1, or 2 1 2 0. So there are 2 of them, and likewise there are 2 of them here, and likewise there are 2 of them here, because you can make any one of them 0, but you have to make the other one 1. So altogether there are 6 possible combinations. So you have to count every one of them. So there's a systematic way of doing it. So you're not missing out anything. That is the challenge in these counting problems. So you notice the way I counted them, I say, let me just finish the first position, then do the second position. So I don't have to count the first position anymore. Then do the third position and so on. So that is a cool way of counting. Okay, the next thing that we want to do is problem number. Well, how many of you got 6? Hopefully many of you got it. I'm happy to see that a large number of you have got quite a few answers. Maybe that is why you came here. You want to see how well you did. And the other people didn't get many, so they didn't bother about coming. Pity, because the less you know, the more you learn. Repeat that. The less you know, the more you learn. So if you didn't know much, and you come to this class, you learn more than the others who know quite a lot, but they learn less. My motto is, if I get 90%, I don't tell people I got 90%. I tell people I lost 10%. And I want to know, where did I lose those marks? And that is a learning process. But to crow about the fact that you got 90% is not a learning process. All right? I hope there is a little lesson for you guys. Go and find out what you don't know, then you are making progress. Okay, problem number 16. We're going to problem number 17 now. The average of 10 scores is 80. When the highest and the lowest scores are removed, the average of the remaining scores is 70. What is the average of the 2 scores that were removed? All right, so this problem here, it appears to be very difficult simply because you've got 10 numbers and you don't know what they are. You only know their average. So let's look at the 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So there are 10 scores, 10 numbers. The average of these scores is 80. So what does that mean? That when I add all these 10 scores, what is that equal to?
$80.
If you add up the whole 10, you will get 80?
So 800 because the average is 80, so 80 times 10.
Correct, yeah. Correct. So the sum will be 800. In averages, there is always a sum and there's some kind of a division process to get the average, right? So the sum of these 10 numbers is an important number here, it's 800, and there are 10 numbers. Now, the the lowest and the highest scores are removed. Suppose you got this in increasing order. So these are taken out. These are removed. And now you have, these are the only ones that are left. And the average of these is 70. So what's your conclusion? What do they add up to? They add up to?
Oh, so is it 560?
The average of these numbers, there are 8 of them now. The average is 70. So what is their sum?
500.
560. 70 times 8, right? So now we have a lot of information because we know what these numbers add up to. We know what a whole lot of them add up to. So we immediately know what the first and the last will add up to. What do these two add up to?
So they add up to 240.
Yeah, it's 240 because
120.
yeah, 560 the 8 and the other two will have to be 240 to make up 800. So those two numbers add up to 240. So what is the average?
So 120.
That's right. So what is the average? Who said the 120?
Almost.
120.
Yeah. There was somebody else who said 120. Who was that? Okay. Now she's too shy to tell me who she is.
So
Okay,
I
Nicholas.
said,
Oh, was it Almaz? Okay.
yes, sir.
Okay, good, Almaz. You are answering very well. What grade are you in, Almaz?
So grade 7. But I usually write the grade 8 sometimes.
You're in grade 7.
Yes, sir.
Right. Now, the rest of you should know why I asked her what grade she is in, because she's got a very young voice. So I suspected that she was rather a junior, and she is in grade 7. Well done, Almaz. We have great hopes for you, because you keep answering all very nice questions. Okay, so the answer to this problem is 120. And Nicholas, also, thank you for helping me along with that. Okay, how many of you got 120? Okay, a number of you got 120, although you weren't too enthusiastic about answering my queries. Too shy. Never feel shy. When you give an answer and it's wrong, it's of great benefit to the others, because then I will tell them how to correct it. They all learn. So it's not about what you say, it's about what others learn. See, these are very important principles in life. Always do the right thing. Don't worry about, yes, the little ego, so don't bother about it. Don't feel shy. Now we are going to number 19. Now can you see all these problems? You'll notice I didn't go to my blank page at all. I didn't use the whiteboard. In fact, I did very little mathematics so far. In 18 problems, I've done very little mathematics. Hardly any calculations. No complicated things, solving equations and having complicated pictures. This is true problem solving. I must commend the people who set these questions, because they make you think and understand what these words mean. You see? And we still got many more of that, like this one here, number 19. A
Sorry.
Prof ask, yes, sir.
I think you might have skipped problem 18.
Oh, I did. Okay, let's go to problem 18. Oh, okay. Okay, thanks for that, Nicholas. Okay, if xy minus 2y equals 10, see what a simple equation. Xy minus 2y equals 10. And again, x and y are grade R numbers. Positive integers are 1, 2, 3, 4, so on. They are grade R numbers. So it's nice to say grade R numbers so that you'll know that it's a very easy problem. Okay. So what is the sum of all the possible values of x? Well, let's just rewrite this nicely. You get y times x minus 2 equals 10. So again, you've got a product of two numbers equals to 10. Right? So both of them are factors of 10. So they want to know the values of x. So let's look at what the possible values for x minus 2 are. So x minus 2 equals, it's a factor of 10. So what are the factors of 10? The first factor, the smallest factor is 1, or what's the next one? 2, or
5,
5, or
10.
10. Those are the only 4 factors of 10, right? But you need to know what are all the possible values of x. Can you just think about it? I'll come back to you now. I'm sorry, Anand. In both cases, I was a meeting. Right now, I'm actually in a class. But quickly tell me what the finding is. Oh, yeah. Oh, so it looks like it looks as if there was you were, yeah. Then we can yeah, yeah. Okay. Thank you very much for that. Huh? I'm sorry I had to make you call me twice, but okay. Okay, bye. Okay, I'll get back to my class. Thanks, bye. Sorry, I had to take that call. It was a call that I was waiting for. Okay, so x minus 2, but then if x minus 2 is this, then x will be just 2 more than each of these. 3, 4, 7, and 12. Right? Easy. Adding 2. Anybody can add 2. And you want to add up. These are the values of x. And when you want to add up, the sum of all these will be that, and that is 26. 7 plus 7 is 14 plus 12 is 26. Okay, so although this is problem number 18, it's not such a difficult problem. Right, tell me now, how many of you guys got that one? Okay, so there are 10 people who raised their hands. Yeah, what is important here is that you've got factorization. You've got products of 2 integers, gives you 10, they're positive integers. So you've got factorization of, the factors are going to be all positive. So that is why you simply write down all the factors. Sometimes we don't want to do that. You say, oh, there must be only one answer. But it's not like that. Very often in integer problems, there are a couple of answers, and then the questions usually ask for which is the smallest and so on and so forth. Okay, I think the heat in my room is overdoing its work. So I had to take this heavy jacket out. Okay, now let's go on to problem number 19. A fruit basket contains bananas and grapes. The ratio of bananas to grapes in the basket is 3:8. When I remove one banana, the ratio changes to 1:3. Now, how many grapes are in the basket? Now you may say, hey, wait a minute. There's bananas here and there's grapes here. And so the one banana is removed. So it should be 2:8, and the ratio there is 1:4. So there must be something wrong with the question. Tell me what is wrong with that argument. I got 3:8. So I can remove 1 from here and I'll get 2. So the new ratio is 2:8. It should be 1:4, but they say it's 1:3. So what's wrong with that argument?
You said it's like totals, but it's actually a ratio, so it could be any number. It just needs to have the correct ratio.
All right. Okay, that's good, Roland. So actually, when you say 3:8, the actual number, this is the ratio. The number the numbers will not be 3 and 8. It will be 3 times something. and 8 times something. Agreed? But there's something that has to be the same. It might be 6 is to 16. There you're multiplying by 2. Or 9 is to 24. There you're multiplying by 3. But you're multiplying by the same number. This is very important. When you have a ratio, then the numbers can be actually written down, but there will be an unknown. And that unknown is that factor. So now this will be the actual numbers. And now you can remove the 1 from the first one, right? And this is remains like that. And now this ratio becomes 1 is to 3. That ratio becomes 1 is to 3. But now this is just, a ratio is just a fraction. So it's 3x minus 1 over 8x is equal to 1 over 3. Right? Now in grade 8, I had a very nice teacher. You will say, you multiply these two, and they will be the same as the multiply of the extremes. This product of the means is equal to the product of the extremes. When I was in grade 8, this teacher said that, and I still haven't forgotten that. So in actual fact, what's happening is, but he didn't tell us this, that this is just a fraction. 3x minus 1 over 8x equals 1 over 3. So therefore, if you multiply these two, these are the means, it's equal to the product of the extremes, cross multiply. Okay, and then you have an equation here, and I'm not going to go into that. If you solve for it, you get x equals 3. So the number of grapes in the baskets, the number would have been x is 3. So the actual numbers are 9 and 24. That's 3x, x is 3. Now when you remove 1 from here, this ratio is 3 over 8, as you can see, 9 over 24. And you remove 1 from it, becomes 8. And 8 over 24 is certainly 1 over 3. So that's very nice. So this is the bananas, and these are grapes. And the question is, how many grapes were in the basket? So the answer is 24. You could have did it by trial and error. You could have just said, okay, now 3 over 8 equals 6 over 16, equivalent fractions. Keep multiplying by 1 and by 2, by 3, multiply numerator and denominator by 4, trial and error, and then remove 1. Here, when you removed 1, we saw 2 over 8 is not a quarter. If you remove 1 here, you get 5 over 16. You're only removing 1 banana, only the numerator. 5 over 16 is not 1/3. And here, if you remove 1, you see 8 over 24, which is 1/3. So this is the correct one, right? And the grapes are at the bottom. And bananas are at the top. Okay. So that's problem number 19. Let's get on to problem number 20. Okay, a rectangle is cut into 2 regions by a single line from one corner to the other, as shown. The areas of the 2 rectangles are in the ratio 1 is to 5. The areas of the regions. Okay, now we're getting into the areas of the 2 regions. 1 is to 5. So, okay, if this area is A, you see, I can simplify the problem very nicely by reading it nicely. And the areas of the 2 regions are in the ratio 1 is to 5. So if this area is A, this area here is 5A. See? And the question now is to find the length of A. So if you look at it, we also know that A plus B is 48. So you know that this entire side, oh, you know one side of it. One side of the rectangle. Okay. So how does one go around doing it? We got a rectangle and we also got a triangle. And we can't find the area of a triangle. This area of this triangle here is half base times, this is 90 degrees here, right? So this is a right angle triangle. So it's half, if you take this as base, then this will be the height. So the area of this triangle is half base times height. But we don't know what this is. Let's give a name and we call it x. So what is A equal to? A is equal to half A times x, half base times height. Right, now we got a trapezium here. But the area of a trapezium, is a little bit complicated. But why should we go to the trapezium? Why don't we go to the rectangle? The area of the rectangle is 6a. It's very nice. See? The area of the rectangle is 6a. And we know the area of the rectangle is length times breadth. So it's 48 times x. So you get two equations now involving a and x. See? Two equations involving a and x. So the 6a means the area of the rectangle on the one hand is the sum of these two pieces, but it's also length and breadth because it's the area of the rectangle. So now you got these two, you can quickly eliminate a by multiplying this by 6. So you got 6a equals 48x. But then I know what 6a is from here. 6a is 6 times half times a, x at least. 6a is equal to 6 times this. 6 times half is 3. So it's 3ax. So you have this equation. Lo and behold, the x's cancel. And you got 3a equals 48. And it's a nice simple equation involving a. A is 16. A is 16. And that was the question. Determine the length of A. That was the problem. So we just solved it. You can calculate B and so on, but you can check your answer. But when you check it, you'll see everything works out quite nicely. The ratio A is 16, and this is 5 times 16, which is 80. And the area of the rectangle is 96. You can check everything out nicely. All right, so let's go on. And the small a is 16, but big A is something else. Okay, we won't worry about that. You only needed to know the length of A. So let's go on to problem number 21 now. I don't think we're sort of somewhat doing well for time, but not quite, because the last few problems take longer time, and we've got 15 minutes. Okay, problem number 21. In the diagram, the outer semicircle has radius 2 centimeters. So this radius here is 2. That's the outer semicircle. And the inner semicircle has got radius 1. Okay. The radii are equally spaced. All right. So, what percentage of the entire shape is shaded? So you draw a semicircle here and you draw another semicircle. And this semicircle is divided up into several pieces, pizzas. Hey, that's interesting. I never thought about that. The word pizza and piece, pizza, pizzas, maybe Italian word for piece is pizza. So the Italians will go to the pizza maker and say, in Italian, no, pizza. That means give me a piece. 1, 2, 3, 4, 5, 6. So there are 6 pieces in this half a pizza, half a circle. And the shaded part here is occupying only 4 of those 4 of those spaces. See the shaded part. So as you can see, you got that, that, and that. So 4 of those pieces are occupied. So this angle here can actually be calculated. By the way, they say the radii are equally spaced. So what it means is that all these angles are the same. 6 angles add up to how many degrees? 180, right? Because it's a straight line. 6 of these equal angles add up to 180. We want to know what 4 of them add up to. 6 angles add up to 180. Each of these is 30, and 4 of them will be 120. So the angle that we have here is in between is actually 120. Let me try to erase these things. So the angle, I want to know this angle here. This is an important angle here because the shaded part is spanning this angle here. That angle is 4 of these 30 degrees, and that's 120 degrees. But 120 degrees is 1/3 of the full revolution. Why do I say that? Because if I want to calculate this darkened area, okay, let's give a name to the darkened area, right? That's what percentage of the shape is shaded. Okay, give a name to the shaded area. Shaded area is X. Let's call it X. Right, do I have an equation involving X? Because I need to solve for X. Anybody can construct an equation involving X. X is the shaded area. I'd like to add the shaded area to this piece here. In which case I will get the area of this entire pizza slice. So X plus this area here X plus that one is equal to the area of this entire piece. Now this area here is 1/3 of a circle because the angle here is 120 degrees. So this area of this piece which is shaded is 1/3 the area of the white circle inside, because you can see it's 120 degrees. You see, you can breaks up 360 degrees divided into 3 equal parts. So, but the area of the circle we know, because it's pi times its radius, pi times 1 squared, pi r squared is the area of a circle. And this part here is 1/3 the area of the full circle. The area of the full circle is not drawn, but because it's 120 degrees, then it's 1/3 the area of the full circle. When you add these two, you'll get 1/3 the area of the large circle, you see? That's beautiful. So it's 1/3 the area of the large circle. And the area of the large circle is pi r squared, and we already know the radius for that is 2. So it's pi times 4. So there it is. You got your equation. And x is now simply pi times 4 divided by 3, which is 4 pi over 3. You take that to the other side. Pi times 1 squared is just pi. That's pi over 3. You take it to the other side. And there you have x is equal to 4 pi over 3 minus pi over 3, which is 3 pi over 3. And 3 pi over 3 is simply pi. So the area of this is pi. Well, in real life terms, this is a contradiction because this is not the pi. The pi is the whole thing. It's a pizza pie. So they say this is pi. Right? That's not true. But the area is pi according to the mathematics. Anyway, people on Pi Day, they like to use pies, and many of these pie shops, they use Pi Day as a nice means of advertisement. Okay, how many of you got the area is pi?
Prof, do we not still have to answer the actual question?
Percentage.
Oh yeah, oh, what percentage of the area? Oh, what percentage of the area of the entire shape? Oh, the entire shape, oh yeah. The area is pi. The area of the entire shape is half, you want a percentage, right? So it's half the area of the full circle. And the area of the full circle, as we saw, was pi r squared, which is 4 pi. Right? So that is the area of the full circle. And we're working out the area, the shape is a half a circle. So half the area of the full circle. Area of the full circle is pi r squared. And this is, when you simplify, the pi's cancel, and you have, and as a percentage, half is 50%. Right, so the question is, how many of you got 50%? You might have tried to guess the answer. You probably would. If you guessed it, you went to 50%, bingo. You got so many marks for nothing. I don't like asking questions like this. I like to have my answer as 47.5%. So nobody can guess it. It's bad. There are people who just guess it, not knowing for any reason, no rhyme, no reason, and they will get the full answer and you got 8 marks or something, problem 21. Okay, let's go on to the next question. The next question is a probability question, and it says, the faces of a fair die are numbered 1 to 6. When the die is rolled, one number will be face down and the other 5 numbers will be visible. Then they say the probability that 210 is divisible by all the 5 visible numbers is A over B. In its simplified form, what is the value of A plus B? Now, if you read this question again, what it says is that you got a die, and when you roll this die, one of the faces is down, but there are 5 visible faces. Right? The one which is down you can't see. Right, okay, at that part we can understand. But now it says that when you multiply the 5 numbers, all these, oh no, not multiply, that 210 is divisible by all the 5 visible numbers. Right, so the numbers in a die are 1, 2, 3, 4, 5, 6. Now, the 5 visible numbers is each divisible by, well, 210 is divisible by the 5 visible numbers. You can see clearly that one of these numbers does not go into 210 quickly? Anybody can see it quickly?
4.
4. Because the last 2 digits is 10, isn't it? And 4 is not a factor of 10, isn't it? So 4 is not one of the visible sides. See, you have to interpret this because all the visible sides, the numbers go exactly into. So the invisible side must be 4. So the bottom one is 5. You see. Okay, now we know what the bottom one is. The bottom one has to be 4 because that's the only one which is not a factor of 210. All the others are. 1, 2, 3, 4, 5 are. Right, now we have to ask ourselves, what is the probability that this situation happens? So if you retranslate that question, the question is exactly the same as saying, what is the probability that 4 is at the bottom? Come on, what's the answer?
1/6.
1/6. Right. What is the probability that 4 is at the bottom? 1/6. Only one time out of 6 times will 4 go in the bottom. So, and this is the probability, 1/6. Right. And that's in simplified form. So what is A plus B? 7. It's all about understanding probability, understanding what the question is, interpreting it. And the ideas are not very complicated, but there's a question of understanding and problem solving, right? And this is what really sharpens your intellect. By trying to interpret these questions, and it's all great fun. I don't know how much you enjoy it. I love these things because it really tests to see how much I understand. Okay, let's see how many of you actually got this thing out from 22. We are going on to problem 23 now. "23 people got this out. Wow, that's not bad at all. It was problem 22. See, they made this hard because in grade 10, you haven't cut your teeth into probability. It's in 11 and 12. So those people who said this thing said, hey, this is a grade 12 question. Therefore, it must be one of those hard ones. But they didn't realize that they're working with you guys, right? You're quite streetwise as far as probability is concerned. 23 of you. Not really. Oh, no. Wrong thing. I'm looking at the number of participants. 6 of them left. All right. Put your hands up again. How many? Got 7. For some reason, I can't count. I've lost the place where I could count the number. Oh, yeah. No, I've got it. Okay. Still almost 50% of you got it. 11 of you. Now it's getting on to heavy stuff here. In the next problem, you've got a square and you've got a random point inside the square. A point inside the square. Join to the midpoint of each of the sides. Now you've got kind of queer shapes. You've got 4 rather unearthly shapes here. And 3 of those shapes, the areas are given. And the question is, what is the area of the 4th shape? So it certainly looks as if it's quite a difficult problem. Okay, but it's a square, so I just want to redraw the square. Oh. All right, so I've got a random point inside. Random means any. And I'm going to take a point inside there and I'm going to join everything. I'm not going to use this figure here. You'll see why. I'm just going to investigate what happens. Take a point which is somewhere here. Now this is joined to the midpoints. Okay. Now I'm not going to put any numbers here, but what I'm going to do is to solve this problem. I'm going to use the fact that all these four are midpoints, but there is something that I'm going to do which is going to prove to be very useful, and that is I'm going to make four constructions, but they are quite all the same constructions. You join this point to all the four vertices. Might look very complicated now, but you'll see just now why. Right. Now, when I do that, I've got four triangles, the red triangles. Right? And in each of those triangles, the black line is a median because this is the midpoint. See? In this red triangle here, the black line is a median. The median joins the vertex to the midpoint of the opposite side. So here again, the black line is a median. Here is a median, median. Right. Now, it shouldn't be very difficult to realize that whenever you got any triangle, and if you take any median, the area of this piece here, the area of this piece is half base times height, and the area of this piece is also half base times height. Bases are the same, and so are the heights, because both of them have got this height from this point here, like 90 degrees. Both the triangles have got the same height, they got the same base, therefore they have the same areas. The fact of the matter is, or the conclusion is that a median always bisects the area of a triangle. All right, now that's a very powerful statement to make, that the median bisects the area of a triangle. So that tells me that these two will be the same because this is a median, the black is a median. Now you got another area, let's call this B here, so this will also be B. And suppose this area is C, these are areas now. C. And this area here is D, this area is also D. Okay. Okay, so now I've got 8 pieces there, but there are only 4 numbers because there are 4 pairs of equal numbers. Now watch, a very nice thing happens. If you look at A plus B plus C plus D, there are 2 A's, 2 B's, 2 C's, 2 D's in this. And I want to look at A plus B plus C plus D. Watch. I'm going to use a new color so you can see what's going on here. A plus B, or let's say this one here, this looks nice. There's your A plus B here. And C plus D is this part here. See? A plus B plus C plus D is that. And that's the same as the sum of these other two. Because these, A plus B plus C plus D is also these. See, A plus D plus B plus C. So what it says now is that if I remove those red lines which I added, right? If I remove them, then I have my original problem. the sum of the two yellows is equal to the sum of the two blues. There it is. 32 plus 16 is 48. And therefore, this plus this is also 48. How's that, guys? So the area is 28. Okay, now that's something that you wouldn't have been able to see very quickly, but if you investigated this thing carefully, how many of you actually discovered this? I'd like to see if anybody actually discovered that these pairs of opposites are actually the same. I can see at least 3 people. Just hold on. Can you just shout out your names, please? I just want to see for my own edification. Talk to me. Nicholas, right? That's one. Who's the other one?
Joshua.
Joshua, yeah. Okay, good. The third
Nicholas.
one? Nicholas, Joshua, but there was a third hand which went up. Oh, the only 2. Oh, somebody was scratching his head. Right. Okay, let's go on. Nicholas and Joshua, pretty good. Okay, so let's get on to problem number 24. Well done, guys. Oh, we are moved into past 6. So if some of you need to go, but these last 2 problems are the most interesting ones, so don't go away. You're going to take another 10 minutes maybe. Now, problem number 24. Amara jogs from her home to the beach. And whenever I see a thing like that, I immediately draw a diagram. I don't like to waste any time. So, home to the beach. Right? So, what else she says? When she gets to the beach, she immediately home, beach. So when she gets to the beach, she jogs first from here to here. She immediately turns around and jogs back. She's away from home for 2 hours. Her speed going back is 15K. So this is 15. No, going to the beach. So here she's traveling at 15 kilometers per hour. But a return journey is 10 kilometers per hour. Well, you can understand. She's on the last lap now. She's tired, so her average speed has dwindled down to 10 kilometers per hour on the return journey. And altogether, it takes her 2 hours. How long in minutes did it take her to run from home to the beach? Now, let me tell you that I solved this problem in 1 line. And I'm going to tell you what that 1 line is, because I don't know how many of you actually saw that rather ingenious solution. I don't think even the web page has got a 1 line solution. The argument is that I use ratios. The ratio of a speed, 15:10. She's running the same distance, right? Both ways. The ratio of a speed is 3:2. Right? So the times also should be somewhat in the same ratio. Right? I'll explain to you why. Because if you take 2 hours now, the answer is in minutes. So 2 hours is 120 minutes. So you divide 120 in the ratio 3:2. When you divide 120 in the ratio 3:2, one is 3/5 and the other is 2/5. 3/5 of 120, 5 goes in 120, 24 times. So this is 72. It'll be in minutes. And this is 2/5, it will be 24 times 2, which is 48 minutes. So when you divide 120 in the ratio 3:2, you are getting 72:24. Right? But one of these is 72 and the other is 48 in time. Now she will take a shorter time on the down journey, so that will have to be 48. See? And she'll take a longer time in the up journey, and that will be 72. Now you will say, hey, but all this is cheating. Why are you taking these ratios and making them equal? The reason is distance is equal to speed times time. So we want this product here, 15 times this must be the same as 10 times that. Right? Okay, so suppose you wanted to, so my answer is, how long did it take her to run from home to the beach? So that would have been the shorter time. So the answer is 48. Answer to this problem is 48. Okay. Now, suppose you did it in another way. You said, suppose it took me little t hours to get to the beach and capital T hours to return. Okay, so it means the distance from home to the beach is speed times time. Speed times time. I'll give names to the unknowns. But it's also equal to 10 times t, because there is also the distance from the home to the beach. So you will see that the ratio of this little time to the capital time, this is 3t divided by 5 equals 2 capital T. So if you put it as a ratio, t over capital T, the cross multiplication allows you to say 3 times t. So there's a 3 here, 3 times t equals 2 times t. This is equals here now. So we're doing the inverse of cross multiplication. T over t must be not 3 over 2. Some people think of it as t over t is 3 over 2. That's wrong. Because to get this, you'll have to cross multiply. Right? So the ratio of the times, the ratio of the times is 2:3. And that's what he said earlier on. And the entire time was 2 hours. So you have to divide 2 hours in the ratio 2:3. That's what it is. The entire time was 2 hours. And that's exactly what we did. We divided 2 hours in the ratio 2:3, and we got 48 and 72. Right? And we needed the 48 because you needed to know the little t. That's your unknown. See, so this is just exactly a ratio problem. Of course, you could use a lot of people will do all kinds of other things and so on. We'll get to the answer, but they can be very complicated. But this is such a simple solution to it. It's an ordinary problem of proportion. And using the formula, the distance times t is equal to, speed times time is the distance. How many of you got 48 minutes? So there were 3 people, 4 people raised their hands. Okay, that's good. Can you just talk to me, then I will know who you are. Just one moment, please. Yeah, talk to me. Who are the 3 people or the 4 people?
Yeah, Prof.
Nicholas?
Me, sir.
Brayton, well done.
Pooja.
Pooja, good. And who else?
Joshua, Prof.
Joshua. Hey, Nicholas and Joshua, you are heading home, man. Right. And the last question, number 25. Number 25. Okay, there are 18 people left. I thank you very much for remaining to the end. Now, problem number 25 is this one. Let's just clear all these drawings first. Get rid of this. All right, this one here is probably one of the toughest ones. And it's 25 after all. When the 7 numbers, 13, P, 16, 7, 4, 15, 7, are arranged in ascending order. Now let's start arranging these numbers in ascending order. Okay, I've got 4, 7, 13, 15, 16, 17. That accounts for 6 of them. And there is this P. We don't know what this P is. It's somewhere here, but we have to place it somewhere. Depending on its value, we have to put it in its correct position. Right, so P is an unknown in ascending order. The median, the middle number, right? We don't know what the middle number is. If P is here, then the middle number will change, you see, depending on where P is. So the middle number is an unknown, but we do know that the middle number is the same as the average of the 7 numbers. Now let's just see what the average is. That's easy to calculate. Yeah, you got 7 numbers. When you add up all these things, you get 67, 33, 48, 61, 68, 72. So it's P plus 72 over 7. That's the average or the mean. That I can calculate in terms of P. Okay, so we're halfway there, but this is actually equal to the median. Now this we don't know what this is. It's not P, we don't know where P is. So it all depends on the position of P. All right. So just suppose that P is, you see, the problem arises if P is sitting inside here somewhere. Then we don't know whether P is to the left or to the right of this thing here. So let's take the case, we don't know where P is. So P is either to the left on this side or to the right. Let's take P to be less than or equal to 15. And try to logically see what happens. Now, suppose P is less than or equal to 15. So in other words, P is somewhere on this side. Right? So, if that is the case, what will the median be? See, P could be, if P, okay, suppose P is like 2. Right? Then you got 2, 4, 7, and the median will be 13. Right? Okay. Now, suppose P is anything less than this, median will be 13. Even if P is equal to 13, right? Then 13 will be the median. P will have to be put in here somewhere, and 13 will be the median. Right. So whatever the case may be, if P is less than or equal to 15, then P will, okay, P equals 13. It could be 14. Suppose P equals 14. So P could be 13. P could be 14. And if P was equal to 15, then P could be, then it will be equal to 15. See? All right. So if P is less than or equal to 15, these are the values, possible values for P. And those values are equal to to the average. So you got numbers like 13, 14, 15 divided by 7, 13 plus 72 divided by 7, or 14 plus 72 divided by 7, or 15 plus 72 divided by 7. Right? And in all these cases, you've got so if P is equal to 13, you'll see that it can't work. 13 plus 72 divided by 7 is not equal to 13. See? Or 14 plus 72 divided by 7 is not equal to, that's 86, it's not equal to 14, for P equal to 14. And again, if P is equal to 15, 15 plus 72 divided by 7 is not equal to 15. So these medians, it doesn't work. So therefore, P must be greater or equal to 15. So if P is greater or equal to 15, it has to be, the only possibility is so P is somewhere here. See? So if P is here, then the median so even in these cases it doesn't work. Oh, I'm going to quickly just look at my argument. I'm sorry, please forgive me. Let me see, I've written out the solution, so you can argue this thing out. Sorry. So here it is. Let us try to place P somewhere here. We already got this. If P is less than or equal to 15, the median is 13, 14, 15. Right? These are the possibilities. So the mean is equal to any of them, right? And which yields solution of 19, 26, and 33. We are solving, in each case we solve the equation P plus 72 is equal to 7 times the median. Sorry. So what we have here, so we got P plus 72, this is the mean. P is equal to 13. You got P is equal to 7 times 13 is 91, minus 72, that's 19. So if P is equal to 13, then P equals 19. Nonsense. Right. If P is equal to 14, then you put 14 plus 72 is 86. And here you got 91. Yeah, so if P is equal to 14, you have the same kind of a thing. 14 times 7 is 98. And then P is equal to 98 minus 72, which is 22, 26. So you have P gives you these values if P is equal to this, and that's impossible. None of these values are equal to any of these. So therefore, this is not possible. So therefore, P is greater or equal to 15. See? And then in that case, P will have to be, the median will have to be 15. The median is 15. See? Because now when you place P somewhere on this side, the median will be the fourth number in 7 numbers. The median is 15. And then once you take this and make that equal to the median, then you see the value for P comes out to be exactly 33. And that's the answer. I'm sorry I took so long over that, and we've exceeded our time by almost, by 26 minutes. Thank you for listening and staying around, the last 18 of you. Did anybody get P equals 33? I would be really interested to know. Ah, well, we've got many people in this class who are going to be in the top 100, I can tell you that. I look forward to seeing who the people are. And 8 people got 33, I'm sure. I struggled with it, but you guys solved a tough problem. That's very nice. Okay, guys, now I just want to tell you, I haven't seen the chat column. I was going to stop the share, and we're going to go to the oh, Amma says you are an amazing professor. Thank you, Amas. I don't know whether I was really that amazing. Now, sorry, Prof, please may I know just the answer to question 7, as my interest was not working at the time, or internet, but I did get the solution. Thank you. Michaela, are you still there, Michaela? Michaela, are you still there? Or maybe internet is still not working again. Okay, maybe she'll write to me, hopefully, and I'll tell her question 7. Okay, so thank you for all your comments, and you always write very nice comments. And it's very unlikely I'm going to see you now, because I'm not giving tuition for the 3rd round, but not for training of the 3rd round, because it's very hard to train for the 3rd round. At least in the 2nd round, it's somewhat predictable, as you might have noticed. A lot of the ideas in the 2nd round were already there, incorporated in the ideas in the earlier ones, and you got a lot of nice clear notions on how to solve problems of various types. So this kind of assistance was useful. But for the 3rd round, anything goes. I will still have some classes depending on what the South African Maths Foundation have in store for me. But yeah, so even they have run out of funds. So if I will continue my classes whether I get paid for it or not. But then I will choose some very nice, interesting problems, and I will ask them to continue with the Google platform and inform everybody so that you can all attend those classes. I will do challenging problems, maybe about 6 or 7. I'll give it to you in advance, and then you can have a look at it. But when we are going to start, I don't know. Just keep an eye on the Google page and keep an eye on your notices, and you will come to know sooner or later when I'm going to start these classes again. I must thank all of you for attending these classes, and especially those who have been contributing in a very positive manner to this class, and even the other ones who are the quiet, shy ones. Many of you got most of the answers. Hopefully, many of you get into around the last 100. The last 100 to go to, oh, wait a minute, that's junior, that's not the senior class, that's junior. I think I'll do a couple of round 3 problems, junior round 3 problems. Maybe I'll do 2 years or something like that, because I don't want to take too long and abuse the privilege you have given me to go up to half an hour, 1 hour after the time. It'll take exactly to choose some nice problems from round 3, and we'll discuss only those. So depending on whether you get into round 3 or not, you are quite welcome to attend these classes. Now, if you think that you can learn something, come, everybody will be invited. So don't bother about whether you got to round 3. Those are the highly privileged people, but it would be very nice if you did. And I would like to see some of you there. And if you're not there, don't bother. It's 100 people out of an initial enrollment of almost 35,000 people get into the final round. You can repeat that to your parents. If they say, what? You couldn't get into round 3? I thought you were good in maths. We just tell them, Mom, 100 out of 35,000, the chances are 1 in 350 for me to get into round 3. And if I did, I'm pretty good, right? Okay. Guys, if you got any comments to make, you can put it in the chat column, and I will be, I'll listen to it. And maybe if you put your email address and you got a question, I can write to you to find out what it is. What's the question?
Sorry,
Okay,
Prof.
Pooja. thank you for all the nice statements.
So thank you for the lesson. Have a great day.
I will
Stay safe.
definitely.
Also, I like your
Bye,
periodic
Mars.
table.
Thank you for the lesson, sir. Bye.
Okay, my dear. Thank you. Bye.
Sorry, Prof.
Yes, Zara. Oh, no, Nicholas. Yes, Nicholas. Nicholas, how many
What
did
do
you
think
get
would happen?
altogether?
I got everything correct except for one question. I messed up on number 6. I read it incorrectly.
Wow. Well done, Nicholas. I'm so proud of you.
Thank you, sir.
Which school are you going to,
what-
Nicholas?
St. David's, Marist in Joburg.
St. David's.
Yes, Prof.
So St. David. Is it St. David or St. David?
St. David's.
In Pietermaritzburg.
In Joburg.
In
sir.
Joburg.
In Sant.
Oh, all right. Well done. I'm so proud that you got 24 or 25. Then you're probably one of the highest in the country. That'd be very nice.
Thank you, Prof.
Yeah.
Prof.
Yes.
Oh, what do you think you would have to get to be in top 100?
Oh, I don't know. It's all relative. They will take all those 5,000 people who wrote and they will rank them to say, okay, how many people got 25 or 25, 24 or 25, and they take the top 100. Now, it can vary from year to year. And you know that there were some years where things were very difficult. You remember? I think 2018 or something like that.
Yes,
I complained that these problems should have been in. Huh?
Last year, I think the top 100 percentage was like 73.
Yeah.
Or if you
Yeah.
get into top 100.
Yeah. So it's all very, very relative. It all depends on how difficult the paper was or how difficult the people found it. And then they'll just take the top 100 from that. So it's quite possible that people can get 85% correct and they still not be in the top 100, or you can get 40% and you can still be in the top 100. It all depends on how many people, how many people you beat. In fact, that is a very, very nice way of determining your ranking in a population. It's called centile. The centile means, are you in the top 5% of your population? So it's independent of how difficult the exam is. You write an exam, everybody writes the same exam, right? The examination may be extremely difficult, and they will only take the top 10 people out of the 100 people and say, these guys, the highest mark was 35%. I don't care, but these guys were in the top 10, the 10 top students of the 100. So it's a centile, right? It's a much more accurate way of determining the ability of a student. In metric, and in grade 12, this is what they do at admission into university. They take the top people from the top, they got everybody's marks, the total marks, right? And they rank them from the top to the bottom for the entire country. And then the universities select them accordingly. Okay? They take centiles. Right. Are there any other questions? Does that answer your question, Nicholas?
Yes, Prof. Thank you. And thank you for the lesson.
No problem, Nicholas. Thank you.
Thank you very much, Prof, for the lesson.
Okay, Nakunkoba. You have a question, Nakunkoba?
Sorry, sir.
Yes, Brayden.
When will we be told if we made it into the third round or not?
Well, that depends. You see, one of the reasons why this thing was delayed so much, you wrote somewhere in the 11th of May or something, right?
Correct, sir.
And you did not get the solutions the same week. Well, maybe the same week or the next week. I didn't discuss the solutions with you because some schools take a long time to return the scripts, or some people post the scripts and it takes a very long time. So only when the central office gets all the scripts, then they say, right, now you can have the class, because now the solutions now become an open book, until such time they know that the scripts are not with this. Some schools might just hold on to the scripts and hope for the mark to be put out and they can change the marks, So to avoid that is why we delayed for so long. So that doesn't answer your question completely, but it will answer it partially, because so only from now they will mark it, but it shouldn't take long to mark it at all, because how do you put on the mark? Do you shade the answers or do you write down the answers?
You shade them, sir.
Or you shade the numbers from 1 to 100 or something?
Yes.
Do they say that all the answers are from 1 to 100?
1 to 999, sir.
Oh, so you shade the correct answer. Okay,
Yes.
so that means the computer is doing the marking. Because shading,
Okay.
the computer can read it. So if the computers are doing the marking, that wouldn't take any time at all. You know, maybe just a few seconds. All they have to do is to take all the scripts and just put them there, and the computer will make suck everything up and can calculate the marks for everybody. And there you have it, whether it's 5,000 or whatever. Right, so there'll be no.
Okay, thank you, sir.
But when they will release it, now sometimes these people are very slow in releasing it. So hopefully I'm going to talk to them and ask them to release it as quickly as possible, because then, you know, we can start our round 3 training as soon as possible. Do you know when when the round 3 will be written?
No, sir.
Okay. It should be somewhere around now. Okay then.
So how much do we have to
by the way,
have?
which school are you in, Brayton? Just one more.
In round.
Sorry, sir. I'm in Maranatha Christian School.
Which school?
Maranatha Christian School in Johannesburg.
Oh, okay. Okay. All right. Who was speaking to me?
Lisa. How much do we need to have scored in this paper round 2 to qualify for round 3?
Weren't you listening to what the first person asked?
Oh, yes, sir. Sorry.
Same question. We don't know. We don't know the answer. It all depends on how well everybody else has done. It all depends.
Hello, sir.
Yeah. Zara, you asked me that question, eh? You also gave me a chat question here. You say, I just took the 2 shaded areas and then made it into 1 square. Oh, because if you put them together, they become 1 square. Is that true? That's very, very nice. The top square is centered over the others and the diagonal. Yeah. Oh my goodness. Zara. Are you still there, Zara? Zara, are you there? She got a brilliant solution. Okay. Right. Okay. So somebody else asked a question?
Yes, I just wanted to tell you that the 3rd round will be written on the 22nd of July.
Oh, okay. And so we are at the moment, we're still in the beginning of June, eh? Okay. I may start, I've got all kinds of talks and preparations to make. So I may start this thing, perhaps I'll find out. It may be towards the end of June or towards the beginning of, towards the end of June maybe. But even after the 3rd round, we were going to continue, because I will just carry on. I like doing problems. So I like to do some rather challenging problems to train you for the team competition, if you're going to take part in that. Zara, are you back with us now?
Yes,
Zara?
sir. Sorry, I was having some internet problems.
Oh, yeah, I was praising you till kingdom come. This is problem 15. I don't know how you saw this, that those 4 pieces fit together to get a square. I would never have been seeing that. But anyway, that's interesting. Thank you very much for that. Okay.
I don't think I gave that answer, Prof.
Sorry, Sarah?
I didn't give that answer.
Oh, you didn't give an answer? Oh,
No.
okay. Well, somebody did, and I don't know who this is. Let me just see. Check it out. A brilliant answer. Okay. Who else now? Anybody else has got a question? All right. So if there's no further questions, we will close. And thank you very much. Bye.
Bye, sir. Have a good evening.
I will certainly will have. Thank you very much.